Good morning, Shay. I made you this real quick video to explain how she used the binomial test. So I read her question number 4, and basically she's betting that these top rows, right? TP slash or hyphen comp, E2 slash 3, FQ, this, and WD, that the top rows will be greater than the bottom rows. Okay? Top rows will be greater than the bottom rows. So how she turned this into a binomial test was the following. I hope I don't lose you on this. But again, so she's trying to prove that the things in the green box are greater than the things in the blue box. And if we look at them all, they all are bigger. Every value in the top is greater than every value in the bottom. So with a binomial test, every outcome has to be a yes or no, or a true or false, some kind of dichotomous outcome. It can only have 2 possible outcomes. So her dichotomous outcomes is if the top value is greater than the bottom value. That would be a true. If the top value was not greater than, that would be a false. Okay, so there's like a 50-50 chance on each outcome that the top would be greater than the bottom. Okay, true or false, so far so good, true or false. So again, her question was the top row values, those are correlations, were they higher than the bottom row? So we go back and look at the data again, and every one was in fact greater. The top value was greater than the bottom value. So what's the probability of that happening? Is 1 out of 2. It's like flipping a coin, right? So the chances of the top row being greater than the bottom row are 1 out of 2 if it was by chance, and that's the way she's going. And you look at the next one, it's the same probability of being true is 1 out of 2. And the truth is that the top number is bigger than the bottom number, and I'm saying it too many times, but I hope you get the picture. In fact, every possible outcome is going to be 1 out of 2. Right? Is it true or not? And if you look at all of her different comparisons, you'll notice that they were all greater on top than they were on the bottom. So how many times did this happen? 1, 2, 3, 4, 8, 12, 16. So that's where she got the 16. And mathematically speaking, binomial speaking, it would equal this, right? A half times a half times a half times a half times a half, right? She's multiplying the probabilities of each one being true. So how many are there? There are 16. So you'll take 1/2, raise it to the 16 using your algebra. That means that's 1 over 2 to the 16, and 2 to the 16th is a big number. It's 65536. You divide that into 1. That's where you get the 0.00015. And what that means is that the odds of getting these exact same results by chance are about 1 in every 15 million. 1, 2, 3, 4, 5, 6. Yes, that's million. So in other words, if you ran this same test 1,000,000 times, you should get these exact same results about 15 times, which is not very probable. So that's why she got to reject the null. And I hope that helps answer this. I have to go back to work. So I will talk to you later. Bye.